Today, for my favorite brain presentation, I'll be discussing the amygdala. In this presentation, I will talk about where it is, what it is, and its purpose. First, I will start with where it is. Located in the temporal lobe, it is most well known for its almond shape, making the structure easier to locate, though it is slightly larger and has many connections within the brain. The structure is actually a set of two on each hemisphere of the brain. Each side of the amygdala has different processes that they follow. The left amygdala processes negative information just as the right side, but it also plays a role in positive emotions. The left is thought to have a hand in the brain's reward system as well. The right side is geared more towards negative emotions like sadness, fear, and anxiety. Due to the amygdala having many androgen receptors, there are distinct differences in the structures between the sexes. There is research that supports testosterone leading to a longer development of the amygdala, which leads to increased mass within men. The amygdala has observable differences based off of sexuality as well. When it comes to studying this part of the brain, because of how sensational negative emotions can be, a lot of research is centered around the amygdala's negative emotion processing. It is much harder to find research on the positive processing, and this presentation will be no different. Now that we're familiar with where this part of the brain is and how it comes to be, we will now look at its purpose. The amygdala takes in sensory information and releases responses according to emotional memory. It triggers biological responses by taking in environmental information and stimuli, and triggering other portions of the brain that are involved in emotional responses. The amygdala is hyperactive during fearful, aggressive, and sexual situations, applying emotional memory to each. Fear, the most sensational of the researched emotions involved with the amygdala, is involved with something called fear conditioning, where the emotion is paired to long-term memories. Damage to the amygdala can actually impair someone's ability to feel fear. As for the emotions themselves, the amygdala is activated during fear and aggressive situations, though anxiety still needs more research to tie it directly to the structure. Fight or flight has been found to be similar in all mammals, as our minds activate the amygdala during responses to danger. Bipolar disorders can often be traced to dysfunctioning amygdalas, and the same can be said about those suffering from PTSD. Because the amygdala processes emotional components of the memories, in patients who suffer from PTSD, they will go through therapies that block the amygdala from stress hormones when going through an intense memory recollection. The amygdala is also involved in classical conditioning, such as appetitive learning. Pavlov's dog experiment is a good example, where a dog is conditioned to respond to the sound of a bell after being paired with the stimulus of being fed. Though the amygdala processes the emotional memories, it does not store them, nor does the specific emotional memories for certain stimuli and situations come from specific locations in the brain. In closure, this part of the brain is my favorite due to how integral it is in our biology. Without fight or flight responses and aggression, we may succumb to predators in the wild or lack social structures to persist in large groups. Without fear, we may not have come together at all. I believe that the amygdala, though simpler than other brain structures, is both intriguing and specifically important for the survival of our species and many others. This concludes my presentation. Thank you for watching.